Welcome again to Virtual Science 2021. Today you should have out page 6 and 7 in your notes, and we're going to learn about a little bit about the scientific method. And when we say that this is the scientific method and it says it's a process that scientists use to answer questions, really we could say this is how your brain works to solve a problem. There's nothing special about it or unique about it to scientists. Okay? So here it even says the process scientists use to answer a question. We could put this in here. Everybody, you, me, the auto mechanic, the doctor, anybody. There's another branch of science. It's psychological science or behavioral sciences. And what they do is they study how we think and how we do things and how our brain works and why we do what we do. And really, this is how we solve a problem. That's what they discovered. And it's important to understand how we solve simple problems and prove that we know what we're talking about. So when we're doing really complex ones, we don't get lost in the process. Now, when we have a question a problem that we're going to solve, okay, and it says scientists ask questions about what they don't understand, really, we can say anyone will ask a question about something that they don't understand. Okay? And we're going to state a problem. So the first thing is there's a problem. There's something that you don't understand what's going on. And an example problem that we can work with today is you go into your room and you flip the switch, and the problem is the lights don't work. That doesn't lead us into an investigation. To have an investigation, we need to state the problem in the form of a question. And the question that we're going to have that relates to this problem is, why aren't my lights working? Now we have a question that we're going to be answering. We're going to first do a little research. And we may look for new sources of information, or we may rely on our prior knowledge. New sources of information would be if you look in the library, the internet, make observations of the current situation. Prior knowledge, you know about lights. You've had the lights not work before, so you already have some knowledge about what the problem might be. In this example, we might do some new research and make some observations about the current situation. For example, we might look around the room and the rest of the house and see if anything else is on. Okay? That new information will help us answer this question. Maybe we're thinking the bulb might not be working. Maybe based on this research we discover that the power is out. Maybe there was a storm or something and the electricity is just not working. And in order to solve our problem, we're going to come up with a hypothesis. And the hypothesis is our educated best guess. We educated ourselves in the last step when we did the research. We looked around the house. We saw that the power was on in our room. The alarm clock was still working. The fish tank is still bubbling, or whatever else you have plugged in your room. The phone charger is still lit up. Okay. So based on, this is an educated best guess. And it has to be an if-then statement. And what we mean is we're going to say, if we do something to the IV, then the DV will respond. The IV is the thing that we're going to change, and the DV is the thing that we think might be dependent on that. So the independent variable is the thing we have control over, and what we think will happen, okay, is the dependent variable. So in our example, the IV, what we control or manipulate is the light bulb. The DV is what we think might be dependent on the IV or the light bulb. Okay? And the DV in this situation is the lights will work. That's what we think might depend on a new light bulb. Okay? So our hypothesis could be, if the light bulb, which is our independent variable, is replaced, then, and this is our dependent variable, the lights will work. Okay, so here we said the independent variable was the thing we could manipulate, which is the light bulb. The dependent variable is what we think will respond to that. Okay, and what will respond to it is that the lights will start working. Other examples of an independent variable and a dependent variable might be if we go outside and the plants in our garden aren't growing well enough, and we think that we won't solve that problem. Okay, so the problem is the plants aren't growing. The question is, why aren't they growing? Our hypothesis might be if, and then we have our independent variable, what we can control. If I add fertilizer to the soil, then the responding variable or the dependent variable will be the plants will grow faster. So what we think will depend on fertilizer is the growth of the plants. So the independent variable is what we control, the amount of fertilizer, and the dependent variable would be what responds to the fertilizer. Sometimes the dependent variable is called the responding variable. What we think will depend on the amount of fertilizer is the plant growth. Now, we're standing in our room and we've decided, well, if I replace the light bulb, then I think the lights will work. But we're still standing in a dark room. So now we need to plan to test our hypothesis. And this includes procedures and materials. Okay, now, most of the time when our brains are solving these problems, we're not actually writing these steps down. We're doing them almost without thinking about them. Okay? But our procedure is going to be go to where we store the new light bulbs and get one, remove the old light bulb, put in the new light bulb, and that is going to include the materials. So we have the procedures, the steps that we're going to follow, and then we have the material that we need, which in this case would be a new light bulb. Usually, if it is a scientific investigation and it's something that we don't understand the answer to, we're going to do the experiment 3 times. Okay? In this case, with the light bulb, okay, would it really be necessary to do the experiment 3 times? I don't think so. Okay? This is a yes or no question. Either replacing the light bulb worked or replacing the light bulb didn't work. So just to review, the independent variable is the one that you control. This is the one that you are changing. So in our example, the independent variable, of course, is the light bulb. That's what we control. That's what we're going to be manipulating. In the other example, what we would control or be able to manipulate would be the amount of fertilizer. The dependent variable is the one that you think will depend on what you do with the IV. So in the first example, we think the lights working will depend on the light bulb. In the other example, we think that the amount of plant growth will depend on what we can control, the amount of fertilizer that we give the plants. The constants are the things that we keep the same as we change the IV. So, for example, in our example, we're going to manipulate the bulb. So there's a lamp in the room or a light fixture that's not working. Would it make any sense if we changed the bulb in the living room? That would be an example of changing the constants, because you went to a different lamp and you changed the bulb out there and then expected the one in the bedroom to work. So the constants are everything that we keep the same. So if we were testing how the fertilizer affected the plant growth, okay, we would not use different plants. We would test on the same plants. And we would keep those things constant. And that's what, really the word constant means constant. It's what you don't change. Controls, if there are groups, this is the group that gets nothing. Usually controls are used when we have living things. So let's say we were working at a company that was developing fertilizer, and we wanted to see if our product was really effective. So we design an experiment and we get a certain kind of plant, and that's going to be one of our constants. Let's say that we want to use tomato plants. So we get groups of tomato plants that are all the same. Another constant would be the kind of soil that they're growing in, the amount of light they get, the amount of water they get, temperature that we grow the plants at. All those things would have to stay the same between the groups. we're going to have one group of plant that gets no fertilizer, a group of plants that gets just a little bit, and then we're going to give another group some more, and then we're going to give another group yet some more fertilizer. And the things that we keep constant in all the groups between the one that gets none, the one that gets us a little, the one that gets some more, and the one that gets some more, those things that we keep constant in all those experiments are going to be things like the soil, the temperature, the light they grow at, the amount of light they get, the amount of water. The control group would be the group that gets none. So that would be the group of tomatoes that gets none. If all we did is test fertilizer and say, well, the plants grow great with fertilizer, how do we know that it actually did anything? Maybe the plants that get no fertilizer do just as well. So in order to really say our fertilizer works, we have to be able to compare it to plants that didn't get any. They do this with medicine. Let's say we were developing cold medicine, and we had one group of people who got a cold, and we gave them no medicine, and then we have a new product that we think might help them get over the cold. So we're going to give the other group the medicine, and we're going to see how long does it take for the people who had no medicine in our control group to feel better, and compare that to the people who actually got the medicine. Now see, if we didn't have the control group, and we just had the sick people and we gave them the medicine, and we said, well, they seem to feel better after 5 days, so our medicine works. How can we really say that the medicine works? Because we don't know how long it would have taken them to get well if they had taken none. Let's say the control group also gets well in 5 days. Then could we really say that the medicine was effective? No. It took the same amount of time to get well whether or not you took the medicine. That's why you need the control group. Now, if we found in our experiment that the people who got no medicine took 5 days to get better, and the people that we gave the medicine got better in 3 days, then we could make our commercial and say, well, if you take our medicine, you'll get better faster than if you take none. Now, when we do an experiment, we're going to get results. And the results are the data and the observations of what happened. In our experiment, okay, the light bulb will either work or it won't work. So this would just be an observation. Okay? Usually, we like quantifiable, and a quantity means a number or at least some kind of verified observation. Like in our example, the lights came on. That would be a verified observation. Okay? Data that we can measure, and like with the plants, we would want to measure the new growth and say, well, they grew on average 10% higher or 20% higher, things that we can measure. And then conclusion, okay? Our conclusion is going to be basically an explanation of, was our hypothesis correct, and how do we know? We may display the conclusion in a graph. We may explain it with what happened and what did our observation mean. And then lastly, we decide, was our hypothesis right or wrong? If it was wrong, we need to change our hypothesis, and we go back to step one. Why do we use problem solving like this? To be able to prove to ourselves and others that we have the correct answer to the question. So if you went and you said, the light bulb in my room was burnt out, and whoever you live with, your parent or guardian, said, how do you know? You could say, well, I went in and I observed that the electricity was still on. I tried a new bulb. The new bulb worked. And I can verify and prove that I was right. Okay. Now, when we talk about the scientific method, we're talking about things, and this is one important differentiation between an opinion and a scientific investigation. With a scientific investigation, we can prove to ourselves and others that the answer is correct. And this is because we get results, data, and observations that we can verify. You can't use the scientific method to prove things that you can't measure or verify. So an example of that might be the existence of ghosts. There's no way for us to have a verified observation of the ghost. Okay? Other things that we couldn't use a scientific investigation to prove are things that would be an opinion. Is blue a better color than yellow? Okay, some people are going to say they like blue, other people are going to say they like yellow. Okay, that doesn't prove that one color is better than the other one. Maybe we could say at best, well, more people like this color than that color. That doesn't prove that one is better than the other. So things that we can't observe, things that we can't measure, are not scientific investigations. Thanks for watching, and we'll see you next time.